Hello everyone, I've come back with another video. This topic will cover preventive maintenance with counter. As I promised in my first video that we're gonna cover it up. This video we're gonna learn how to use counter as an interval type in maintenance plan. What is counter? So counter is nothing but a unit of measurements by which you can measure an asset and its performance and it is working. For example, an asset's running for a production machine running for certain hours. So hour is its measurements or counter, and like a vehicle, you can say that kilometer, how many kilometers it's run, right? So how many kilometer runs, then that's the maintenance required. And a production machine, again, how many quantity it's produced, and based on that we're gonna do the maintenance, right? There is a lifetime, right, of machines, and based on that also there would be a 3 standard scenario. I'm gonna cover it up. That's in the maintenance plan with counter. One is called repeat from the start date. One is once reached above, another one once reached below. So repeat from start date, we should start. I am going to take the example of counter repeat, which Microsoft documentation said that. I will tell you how these things work. I will also tell you why I'm not convinced on it in different scenarios. I will also talk about certain scenario which it doesn't cover it up actually. So the counter repeat is nothing but like you have a machine which work a particular time period and a particular date, and based on that you say that every 250 you're gonna repeat the counter. Every 250 hours register you're gonna have a maintenance on it, right? So like in this example, if you see 250, 500 and 750, so each and every hour log, and whenever it's crossed that one, it gonna define the maintenance plan. So let's go to the system and see the demonstration. Okay, so that's my system. I came down to my asset management module. I have created 3 assets for 3 different scenarios. So let's find out those assets. So this is a production machine, and in this production machine, how I define the maintenance plan. Let's first see the maintenance plan. So there is a maintenance plan C01, sorry. So CO1, I say that every 300 hours there would be a preventive maintenance, and it should be repeat from the start date, and I put frequency 300 and counter is hour, right? And it should have a service level 1, auto create, and this, and my asset is link over here. So this if we edit this one, we can see there are many interval types. So you can do from plan date, you can do from anything, right? So I'm using repeat from the start date functionalities, right? I active and plan should be active from the first June. So once I done, I activate their assets and I put some counter over here. So here are my some counter. 1st June I have logged 140, and then 9th June I log 121, and I log 100 hours in 12, right? So this is how the machine has been performed. So it is already over to 300, and that must create a maintenance plan, right? So remember, whenever you are using the repeat from the start date as a counter, make sure you have 2 lines of data. If you keep 1 lines of data, it's never going to consider in the plan, right? Because there is a formula in the back that's called rate of change. So So rate of change has a complex formula in the back which has been written based on certain assumption, certain industry specifically, not for all industry. It doesn't work in the all industry. That's where I am coming. So let's go to the system and let's run the plan maintenance schedule, and I run for a plan. So say here I'm going to run from today to next 30 days. Okay, so in the frequency, you see here in maintenance you still need to put a day. Based on the rate of change formula, it will predict when you need to do the maintenance. So I say that I'm going to run for next 15 days time, right? Let's say that any fish is hooked in my fishing rod or not. Let's run that. That's created one, and it is suggesting 26th, 25th, 6th, 25th June, 3 p.m. whatever the time is there, right? And it came from there. So every 300 hours. Now the funniest thing is that if I increase, it's gonna create more because it's coming from a prediction. So now it is again suggesting on another maintenance on 7th. Because it's a prediction base, that system is predicting. Check my trend over here. You see when it is happened, what is the day difference? 1, 9 and 12, right? So what is the day difference? Here is a 9 day and here is 9 to 3 days. And as per the suggestion, if you see here the maintenance schedule, so today is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 9 plus 3 is equal to 12. So please add 13 days plus 12 days. How much is that? 25th. So it is giving you the prediction. You should do a maintenance on 25th. And again from 25th you add another 12 days. So 5 days, and then it's 5 days plus 10 days. So it's the rate of change formula is working on the back. So this is how it's worked. The repeat from the counter. It's more about the normal small machines which you are running in the production industry. It's worked based on that. But there are certain scenarios that it doesn't work like that. This rate of change formula doesn't work. Like my recent implementation, I have faced many issues on it. Just to share with you guys. Threshold means I'm going to running, and the running say kilometer or hour, I don't want this should be predict when it should be done. I want whenever it's reach to that particular threshold limit, it should create. So if I say 3000, that means it should create a maintenance plan when I reach 3000 hours. Then again it will wait and it will do a maintenance again for 6000 hours when it is reached. It should not give me the prediction that when I should do, because the machine run hour or like a ship or like an aeroplane or like a train, you can't predict how much this train going to be run. Like an example for a Japanese Shinkansen, I've been to their maintenance hub for quite a few time in the Kawasaki in northern Japan. So a train, a daily basis, certain trains are running from Hakata to Tokyo. The same time at the night when it goes to 7 p.m, right, it is going in a different direction, and which is around 1200 kilometers, and the Hakata is another side from the western side which is covering up around 2000 kilometers. So it's depending on the rostering and all these things, the train can do a maintenance. And if you run say 100k kilometers, so then the wheel needs to be changed in Shinkansen or the bullet train. And if every day basis you need to see the pantograph, this is the normal inspection actually, like a maintenance round which you can use. So this is where I have a bit of contradiction on this process, but at least it is there. It is running based on certain formula. You guys can utilize that one. If you think the example which is I given, which doesn't cover here, so you have to customize that process. Okay, let's go to the next example. So next example, it's a real life example. It's from a petrol station. My family own a petrol station, so I know this one quite well. This in a tanker, when you own a petrol station, you might have a tanker, right? You own tanker, or you take your own, or you take a rent. And basically, when a tanker has loaded the goods, and that has a calibration, and the calibration, you start in calibration when you end, and there is a calibration, and calibration has a certain deep and the centimeter based stuffs are there. So like an example, I taken my example, I have a 20 kiloliter tanker, and it's carry my HSD and carry my MSD. So depending on the HSD or depending on the MSD, my two different measurement going to be happened depending on what is my deep by centimeter. And deep by centimeter is basically a calibration by which the chart will say that how much the product is inside, right? So that calibration will define that this container can contain 20,000 kiloliter diesel or petrol, which is motor spirit. What happened there if the calibration is keep on unmatching the things, and it's a flag for you. You need to stop this tanker to be used. You should have to send for recalibration processes, and people will see and inspect, and they will check it out where the things needs to be done, what needs to be changed, and all these things. So the example here which I'm going to use, the similar example, my oil tanker. So the oil tanker has a plan, C2O. The C2O is a calibration, and you see once it is reached above, there is a one more interval type which you can see here. It's use only counter, and you see that when the deep frequency reach to more than 50 deep by centimeter, and it should create a work order for us. So similarly, I create some counter data for it, and this counter data you can see here, the value is 45, 46, 40, 45.67 and 44.93 centimeter, because always there is a point actually. So each point is basically 1 liter or 10 liter of HSD or petrol. So if you have a 145 centimeter or 45 centimeter is short, it's quite a lot of amount of diesel or petrol is short, right? So normally in business people give 1 centimeter. If it is go beyond 1 centimeter, that's a huge loss. It's an abnormal loss for them. So this 45, I taken a round figure, so it will help you to understand. So you see here the value is 45, 46, 45.67, 49, 44.93. Every trip we are putting the information here. So if I run here, it should not create any work order. So let's run. So there is no work order, right? So let's go back and increase. So now I'm gonna increase it to deep by centimeter for it. There are big charts for it. You don't need to go to too detail on that. I say that, hey, deep, I got it, just not really convinced. Say 51 centimeter, which is quite a big one, and that's a really big loss. And then I go down and I go and run. I don't care about the days or anything, because whenever it's reached. you see here it's automatically it's came the calibration one and it's created. Okay, so then you go and do the calibration process, and from the work order you can capture a new assessment stuff, that what is the right now recalibrated counter. So you can come down here and reset it and put it in new one over there, right? So this is how the counter based on above, once it is reached above. So you can put it as a temperature. One of the another example, temperature is very big example in the iron industry. If you see the blast furnace, we normally put 2600 Fahrenheit minimum. So this centigrade. So if it is go below, the grade of the blast furnace of that iron ore would be a low quality. So you have to maintain always 2600, right? And then, or sometimes it is go more than 3600, then the entire iron ore gonna be disturbed, right? So sometimes it should not go more than that. Like also a heater, right? Also certain server room, right? Server is one of the very good example that we have to maintain a particular temperature wherever we put the server in the offices, right? So that is one of the examples where you can utilize, right? So now next, go to the next one. Next example, another good example, which is from my another experience from my brother business. Like in ice cream industry, you can see ice cream industry, highly perishable product. The business, if you see, they enter in the ecosystem plan, delivery, track, and dealer. Everyone needs to have a cold environment, which is a freezer, and the freezer has to maintain in such a way it's always maintain minus 21 degree, that the ice cream always keep it well, right? So if you go more than minus 21, there is a ice coming inside in the ice cream, and then ice cream taste is gone. So minus 21 degrees always a standard temperature for a ice cream freezer. So here in the whole ecosystem you have to maintain the minus 21. If certain cases it go beyond more that, it's gonna create an issue, and that means there is a damage of your ice cream. So if it's a van doesn't giving you a certain minus 21 degree, that means the product has a big chance to be a big failure. And in certain cases it's happened, you go and needs to create a maintenance for that particular freezer, and then you can see that what is the issue in the compressor, why it is going more than that. Is there more gases are there or not, right? You have to recalibrate again, right? So which we are gonna see here. I have a freezer. I again create one there, right? And this freezer we say reach below. So this below, the thing is that here you can't put a minus figure because minus doesn't allow it, so you have to customize it. In my project I already done the customization, this change, and on that change actually it's go and support it. So here I put a positive 21 for your understanding, and then I go to the counter and I say 24 degrees centigrade right now, and then because it needs to go below, right? And then I create one more here, say Celsius, I say 20 degree. Right. And now go down there and create a maintenance plan. Don't care about the days. So you see it's created here. So this is another way. Whenever it is reached below, you can utilize this maintenance interval type to create a maintenance work order. The great thing is that what Microsoft is offering, you can utilize the IoT sensor data, and then the IoT sensor data you can link it with FNO system, and an FNO system can capture all the counter information, and based on that you can schedule an automatic batch, and that can trigger a maintenance order, a maintenance plan for you, that these are the probable causes are coming. And also you can keep on putting the data feed inside. So this is what it is in my demo in terms of the three counter based maintenance plan: counter from repeat, counter from reach above, once it is reach above, once it is reach below. So I hope this gonna help you out for your implementation, in your future implementation, how to use this counter. And there are certain lags are there as well, but every product has that lag, so you have to change a little bit, tweak it a little bit to make sure it is based on the industry specific needs. So thank you very much.